some of the like students might think that x was just vanished from there totally and new value was assigned to x, but not, this is not the case. Hey all, in this video we are going to have a look at three very specific topics in Rust which are super important, and first of them are mutability, and the second one is shadowing, and the third one is data types. It might seem like the third one, data types, like very not too much like important, but it is, because there are plenty of data types in Rust that Rust is supporting, and in each of the then cherry on the top is like in each of the data type there are like plenty of range that you can that a variable or a data type can occupy in the memory to store the values. So this, all of these kind of things make amalgam that students don't like able to understand properly. And there is also tools complement strategy that like data types do in the Rust when they want to save some negative kind of numbers like signed and unsigned things. So we'll go deep into each of the things. So let's start first with the topic called mutability. What the mutability thing is. So in the Rust, like mutability stuff, if I talk about mutability, the mutability is simply what you can call like changing the data of the variable. Let's suppose you make an variable, let x is equal to 6. Now in Rust what happens is that you can't change the value of this x variable, because this by default each of the things in the Rust, each of the variable are immutable. You can change the value directly. You cannot change the value directly up till when you will make the value this that specific variable mutable. And how you make this variable mutable is just attaching this mute keyword with this variable. Let's say you just attach this mute word with this x variable. Now you can change this x value at any point of your coding, like x is equal to 8, or this x can be at some later point can be 10. So this x can hold any value at later point when you are coding. So this is the mutability at the syntax level. But what happens when we see, like when Rust is going through this process, and what's happening at the memory side? Let's see at this picture now. So whenever you let's suppose you define some variable x is equal to 6 and you make it mutable, like let's just raise it up and make a mutable variable mute x is equal to, you can call it mut or you mute, whatever you want. So I'll call it mute, like mutable. So when you make a variable x is equal to 6 and you make it mutable, and then what happens, and when you assign a new value to this variable, let's suppose 7 at some later point, so what are the changes that are happening in the RAM? Let's have a look at them. So let's suppose this is the stack. All of the values and data types that are primitive, like scalar data type, we will talk about later at the scalar at the third point, which was data types. What are like scalar and other kind of data types? So this data type that I have defined now is its primitive data type, which is like 6. And there is like some data type i32. If I don't give any kind of like data type, mention any kind of data type with this variable, there is a default data type i32 which is already mentioned there. Like compiler assumes this, that you are giving i32 if you assign some integer there. Okay, so if you assign some integer and you didn't mention data type, compiler will assume this i32, and at some later point you change the value x is equal to 7. So at first what happens, x was pointing to this section of the memory, and this segment of the memory was holding value 7. Okay, so at later point you change it to sorry, this was holding the value 6, and at later point you change it to 7. Now what happened is x was actually pointing to this memory section, and now x just replaces this 6 with this 7. Some of the students might think that x was just vanished from there totally and new value was assigned to x, but not, this is not the case.
Who are you?
X was firstly assigned to this 6, and then whenever you change the value, this reference remains same. This is the important point, like this reference remains same to this segment don't change. And what happens is only this value just discarded the previous one and the new value just replaced at the same segment of the memory. This happens in this mutability case, but this don't happen in shadowing. Shadowing is totally different. So let's have a look what shadowing is and how this works under the hood. So let's suppose you have a variable here. So we are starting out with our second topic, shadowing. Okay, so let's suppose you have a variable here, let x is equal to 6. So you didn't make it mutable, and now at later point what you do is let x is equal to 7. You do this. Now what happened here is x have assigned a new value 7 here, and now this 7 is accessible in all of this next scope. And if you access the if you try to access and operate with x at this scope, like in this region, if I point it out to this region and you try to operate with this x in this region, now the value x is being used is 6. X is totally referencing to 6, and whenever you do x plus 1, it will give you 7 as a output. But when you do this at this line, you assigned a new variable a 7 via let keyword. This is just similar like you are creating a new variable, and you will be thinking like what will be the value of x in this region, what will be the value of x in this region, and this is the important point. Now x will have a new value if you will add some of the number with x, and the output will be not 7, it will be 8, because x is assigned in a very new way, in a very new fashion here, which is called shadowing, because the second value has been took over the previous one. How, you can say, how the compiler is seeing to all of the code of this file, like let's suppose this file is .rs. Compiler is watching all of the code of this file, and whenever a compiler reaches out at this line, compiler says okay, x has a value assigned 6. And now when compiler reaches at 7 line, now compiler will thought and think and behave in a way that x is now assigned a totally new value, and this is a new variable, not the just previous one, but this is a just totally new variable. So how this mechanism happens in memory, now let's have a look at this. After this visualization, you will have you will grab this concept totally and completely. So what happens in the RAM in the stack is, so again I am mentioning that this is a primitive data type. I have already mentioned, if you don't give any kind of data type to this variable, compiler will automatically deduce like it is i32 based on your data, because i32 means integer of 32 length. We will talk about it later. So compiler give it automatically data type, and this all primitive values and scalar data types resides in the stack. This is our stack. This is not the heap or the some random memory, but this is a stack controlled memory. You know the pattern FIFO LIFO. So this is working on this first in last out. So now let's suppose whenever you give x is equal to 6, x is being stored here at some segment here. X is pointed to this segment and 6 is being stored here. And now when you give a new value to x, this is not being giving a new value. In shadowing, this is totally different. This is totally like you are creating a new variable at some different segment which have been assigned a value of 7. Now of course there is an issue like this value which is being assigned to this segment and this variable x, this is totally like dangling now in the memory. This is consuming memory in a very boring way, and this is not useful at all, but it is just useful in this region. Like in this region it is only useful because it is the value of x is only 6 in this region, because in whenever you are starting from this region the value of x is totally changed, and it's not changed but you have declared and initialized a new variable, like you have created a new variable. So calling it, instead of like you have assigned a new value to x, call it like you have created a new fresh variable called x, because x is being assigned a new segment in the memory with the new value. So now on from this x is like implicable, and x has value, x always have value of 7 in this segment, and in this segment x will have only 6 value. So this is the scope of like, so at this time you can just say like this x have scope of this region and this x have a scope of this region. So we'll discuss in a detail like what kind of scopes variables have in Rust in a detailed manner. So this is all about shadowing, and now let's see in a some implementation way how this shadowing and this, like our previous topic, mutability happens in a with a example at code editor. So let's move toward the code editor. Okay, so this folder was for our first episode, and now let me create a new project using cargo new, and let's say this repository name episode 2, and the topics we are covering are we can give the names of topic. I think this will be a too lengthy, so just call it episode 2. So this cargo new episode 2 and hit enter. This will be creating a new folder, fresh folder here with containing like all of the, you can say this is a new project initialized via cargo tool. So this is a new and fresh project initialized via cargo tool, and now let's see how shadowing work and how the other concept like mutability works. So let's suppose you have a variable x called 10, and at later point what you do is let x is equal to 9. I am changing the value, and let's build this via cargo build, and whenever I will build it, it will throw an error like can't assign twice to immutable variable. This immutable variable cannot be assigned a new value at some later point, but you can do it if you will mention some mute here. Now you can give any kind of value to this variable, but this value should only be of the same data type. You cannot change the data type of this value. Like let's suppose I try to change the x at some later point is equal to this name, and if I save and cargo build, this will again throw an error expected integer found string. So what happens in mutability is that like you can change the value data type at some later point, but you can only change the value, because what compiler is doing here is it automatically deducing some type. Like it is, what it is doing is it's deducing like the value data type of this variable is i32, and if I try to change x is equal to this string, I am like going against the rules, because I have assigned the i32 data type here and I am changing the data type totally here. So you can do that. Now let's like this is all with the like mutability stuff. Let me give a heading here, mutability, and let's move toward our new topic, which was like what was the name of shadowing. Okay, so what happened in shadowing is, let's suppose you created a new variable y is equal to 10, and at some later point what you do is let y is equal to 11. Now this is totally fine because this is called shadowing. All of the coming variables just replace of all of the previous variables. Like if at some later point there is a y, this is totally like new variable which will be replacing all of the other variables of the previous scope. So this y is being 10 only in this section, in these two lines. If I try to print out this variable, the same value of 10. Let me comment it out because this will throw the error because I'm changing the data type here. And if I build it and then I just run it, cargo run print ln giving some, oh yeah, because we have to define the curly brackets here because we are giving the variable. So if I cargo run, you can do anything like cargo run or cargo build, it's all up to you. And now if I just print it out like print ln, and I print just y, and let's run it out, and also let's have a print statement here, print ln, and if I print the y here, and let's check the difference between each of them. By the way, cargo run, I have to just run the command this again and again. Instead of doing this, what you can do is just install cargo watch. I have just put put down some of the commands in the previous project that you can copy from here, from the bottom of the file. Like just run the cargo install watch, and this package will be installed on your system. And then you can also have some like this kind of like pretty awesome packages. Rust up component add clippy. If you run this command, you will have this clippy is just similar to like to just make your code a little bit better, uh, like linting wise, indentation wise, and it make the code a little prettier because it set up some of the standards, and it force you to implement the code on these standards. So it come up with some like pre-default some of the standards, but you can configure them. And there is also Rust fmt, which you use for kind of Rust formatting, and there is a command here which can be used to just run run your project in cargo watch, so you don't have to run it again and again via this cargo run command. So it will be running, and you just have to hit the control save, and your code will be auto compiled and run. So you can just run this command in the terminal, and this package will be saved. I have already this one, so I what I need to do is just to run cargo watch. Like I already forgot this command, cargo watch qc, and then dash x, and then run, and then x clippy. So you can like run both of these. Also this command can run the clippy as well. So just hit enter, and your project will be running from the start to the end. Okay, so just hit this save here and switch to this file. Just save this one. Okay, so now our project is running, and if you see in the terminal, you can see the output here. Here it's been typed x y is equal to 10, and then y is equal to 11, which is of this line, and one of them is of this line of this scope. So this is what shadowing was. And if I just remove these line and implement some other thing, like let y is equal to 20, not 20, y plus 1, and then I print it out here on this line. Okay, and then I just print it out at this line as well, one of at above of the scope. So these brackets are saying that this is a block scope. This have its own variables, and these variables are enclosed in this only in this scope. So this y is not accessible in at the outside of this block, and y is accessible, but its value like whatever the value we will change here is not accessible, because y value why is accessible outside of this block scope is because it's defined here. But let's suppose you have some another variable z is equal to 10. Now z will not be accessible outside of this scope because this is defined inside of this scope. We'll cover this scope thing, might be in our next episode or the after the next episode, so we have to just keep the patience on this info yet. So what these variables are defined here are not accessible outside of this scope. Okay, and if I just going to debug this, and let me comment this out as well, because we can see just only the debugging of this section. And if I run, let me show you after running, first after running, and then we will debug. So so the value of y here is 10, and if I print it out here it will be 10, and when I enter in this scope y is equal to y plus 1, this y is being accessible here because this is called like cascading, or you can say this as well shadowing, because this y is being shadowed from the outside of y. So y value here will be 10, which is being used of the outside y, 10, and 10 plus 1 will be 11. So if you print out the y here, it will be 11 inside the scope. If you, and whenever you will get out of this scope here in at this line number 22, y will be again 10, because this scope is just vanished and now this scope is active. So let's debug this as well, and as you can see the output, y is 10 first, then y is 11 inside the scope, and outside of the scope y is again 10 to the back value. So if I try to debug this and run the debugger here, so let's see the values of all of these happening in the RAM, because we are not just supposed to see in what is in front of us, but we have to debug it in the debugger, because we can see each of the value step by step, but because what is happening like under the hood in the memory mechanism. So this is local, this is static scope, this is like global, and these are the registers. There are some kind of 3 registers: general purpose registers, floating point registers, exception state registers. What these registers do is, general purpose register do like keep all of the value, all of the information regarding your main function. All of the stuff that main function is containing, general purpose registers hold all of the value and all of the information, and you can say the data. So, and the at the second point, floating point, there are floating point registers, but this register is to like this hold all of your floating point data that are in like in not in integers but in points value. So, and this, what is this at third, exception state register do this just hold if at some point some exception raises. So like you don't have to remember these and these registers too much, and because all of you we have to concern is related to just local, static and global variables. And if I just run this debugging ahead, what will happen is, you can say local is just empty. And if I, so one important point, this local is taking this all of this function scope as a local, cause this local variable here, local scope here, considering this each of the function, whatever the function you will define, like whenever you define these, you put these curly brackets anywhere, this becomes local scope. Just keep remember that this is our main function, everything is happening inside this main, but this main is being considered as a local inside the debugger. So when I run this this debugger onto a step over, so when I step over this debugger to the next line, see what is happening. Now this line 12 is being executed, and now we have a variable y is equal to 10 in the local scope. Okay, now this variable will be printed out at line 14, and now we are entering in this block scope. And if I execute this line as well, 17, what you will see is y is being replaced, not replaced, like y is the only variable with the name of y in the memory, so that's why a new variable is not is being shown here, but it is being created in the memory. So y value is now changed because a new variable is declared and defined. Now y's value in the memory is y is equal to 10 is equal to 10 plus 1, which is 11 now. And if I execute this line, you will have another x here called which value is 10, and this is of block scope. And if I execute and step over to new line, this will be printed out in the terminal. If I see in the terminal, this is being printed out 11, and now we are out of the scope. And you see what happens, y is again like pointing, y is again like of the its previous scope, which was 10. Like this block scope is just vanished, like went out, because our control of line is now at this line 22. So block scope is just vanished and executed. Now we are again on our previous scope, which is of scope of this function, and at this level y was 10. So this is just the mechanism happening behind the scene at the memory. So might be you are confused with this y, like there should be a new y here in this local, but no, actually the name is same, so that why it was just showing y. But at the memory level, this new variable was created at there. What I have like shown to you in the in this like presentation here, and we have like done with this how this thing was happening in the memory level. So let me show you again. Okay, so if I show you how this shadowing is happening, is x was created and pointed towards this memory segment having value of 6, and when we enter to this scope, what happens is that x is created a new variable as a new variable and assigned to a new segment with a new value. So this was just all happening behind the scenes, and see you in the next episode. Bye bye.